we have here two vectors, x cubed zi plus xy squared zj minus y squared z cubed k, that's A, and vector B is y z cubed I plus x squared y squared z squared j plus x cubed y squared z k. You must find the grad of A dot B. Alright? Now, of course, even though we have vectors, you know that the grad will end up as a scalar. And then the dot product between A and B. A dot B will be a scalar, so you can find the grad of it. Alright? You wouldn't be able to find the grad of a vector, but you can find the grad of a scalar field. So, write this down, pause the video, write it down, and work it out before you finish watching the video. Alright, so you have worked it out. What did you get for it? Let's see something here. A dot B, what is that equal to? Now remember, when you have the dot product of two vectors, it's going to be direction in one times the same direction in the other plus direction in the next time direction in the other plus. For the third one, the third direction in one time direction in the other. It's coefficients of I by coefficient of I. So you're going to have x cubed z, yz cubed, plus, then you have xy squared z times x squared y squared z squared for j, right? Plus, what is going to be minus y squared z cubed times x cubed y squared z for the k part. So it's scalar, you have no directions. So let's simplify it. A dot B is equal to, this would be x cubed yz to the 4 plus x squared by x squared, that's x to the 4, y squared by y squared is y to the 4th, z by z squared, that's z cubed, minus, and you have x cubed times y to the 2 by y to the 2, y to the 4th, times z cubed by z is z to the 4th. So that's what you have. Now you want to find the grad. Now the grad of A dot B is going to be the partial of A dot B with respect to x in the I direction, right? Partial A dot B by partial x in the I direction plus partial of A dot B by partial y in the j direction plus partial of A dot B by partial z in the k direction. See that? Now here, what is the partial of A dot B by partial x? We'll differentiate that. It's going to be 3x squared yz to the 4th plus 4x cubed y to the 4z cubed minus, and then 3x squared y to the 4z to the 4th. Alright. Then what is partial of A dot B by partial y? To differentiate that with respect to y, you're going to have x z to the 4th plus 4x to the 4th y cubed z cubed minus then 4x cubed y cubed z to the 4th. Alright. Then what is partial of A dot B by partial z? Differentiate with respect to z now. You have 4x cubed yz cubed. So it's 4x cubed yz cubed plus 3x to the 4 y to the 4 z squared. It's plus 3x to the 4 y to the 4 z squared. I think these are minus now, no? Alright. Minus 4x cubed y to the 4z cubed. So it's 4x cubed y to the 4z cubed. Alright, see that? Now, that means that the grad of A dot B equals this one, I. So it's going to be 3x squared yz to the 4th plus 4x cubed y to the 4z cubed minus 3x squared y to the 4th z to the 4th I. So it's this part I plus, and this other part j is going to be x z to the 4th plus 4x to the 4th y cubed z cubed minus 4x cubed y cubed 4x cubed y cubed z to the 4th j plus, then the third part now, partial of A dot B by partial z k. So what we have is 4x cubed yz cubed. So it's 4x cubed yz cubed plus 3x to the 4 y to the 4 z squared plus 3x to the 4 y to the 4 z squared minus 4x cubed y to the 4 z cubed 4x cubed y to the 4 z cubed k. So there we have it. Alright, the grad of A dot B. Okay, so next time then.